A warm welcome to all. I'm taking the subject Discrete Mathematical Structure. Myself, Vasant Kumar S., working as an Assistant Professor, Department of Mathematics, Mysore Royal Institute of Technology, Mysore. So, in this, I'm taking a last topic, that is direct proof and indirect proof. So, we should know the definitions of direct and indirect proof. So, direct proof, we assume P is true and show that Q is true. Therefore, we conclude that P implies Q is true. So, what is direct proof? We assume P is true and show that Q is true. Therefore, we conclude that P implies Q is true. You should know the definitions of conditional definition when it will be true. So, if P is true and Q is true, therefore, definitely it will be a true statement. That is the definition of direct proof. Next, if you come with indirect proof, we are going to assume P is true and show that negation Q is true, which is equivalent to P is true and Q is false. Then we establish a definition: negation P is true. We come with a proposition called negation P is true. That is results in negation Q implies negation P is true, which is nothing but a contrapositive. So, what is indirect proof? We assume P is true and show that negation Q is true, which is equivalent to P is true and Q is false. Then we establish negation P is true. We are going to establish a proposition called negation P is true. That results as negation Q implies negation P is true, which is nothing but called as also contrapositive. Next, we shall see another definition of proof called proof of contradiction. So, in this definition, we are going to assume P implies Q is false. P implies Q is false, which is equivalent to P is true and Q is false, which is equivalent to P is true and Q is false. So, here we start with Q is false. So, to find the proof of contradiction, we are going to start with Q as false statement and establish the statement P as false and establish the statement P as false. Since P is already true, why we are saying P is already true? Since P implies Q is false, we are assuming that P implies Q is false. When P implies Q is false, if P is true and Q is false, it is false. So, that is why P is true here. Already P is true here. So, we arrive at a contradiction. Therefore, we conclude that P implies Q is false. Did you got the concept of proof of contradiction? Okay. Let us see next definition called disproof. So, what is disproof? We should know. Here we know that for all x belongs to yes, P of x is true. Proposition P of x is true only when P of x is true for every x belongs to S. For every x belongs to S. If there exists at least one element called x naught belongs to the set S such that P of x naught is false. P of x naught is what? False. Then the truth value of the given proposition is false. Then the truth value of the given proposition is false. This is equivalent to providing a counter example, disproving the given proposition. So knowing all these definitions, we are going to solve the problems on direct proof, indirect proof, disproof, and proof of contradiction. So now let us see the next. Let us solve the problems on these definition using these definitions. Consider problem 1. The given problem is what here? The given problem is if n is true, if n is an odd integer, then we are getting then 9 n plus 9 is an even integer. So here they have given the conditional statement called if then statement. So if n is an odd integer, then n plus 9 is an even integer. Then give a direct proof, an indirect proof, and also proof of contradiction. So next we require to find what is P and what is Q. Definitely we can say that P is what here? Definitely we can say that P is nothing but n is an odd integer. And we can define Q is what? Q can be defined as n plus 9 is an even integer. Okay. So then they are asking to find a direct proof, an indirect proof of contradiction. Okay. So let us see the first proof, a direct proof. Here P is what? N is an odd integer. Q is what? N plus 9 is an even integer. Now if we go for finding direct proof, since P is odd, that implies what? That implies here we should consider the number odd number. So I have considered n as what here? 2m plus 1. 2m plus 1 means what? Odd number. 2m plus 1. 2m is even. 2m is what? Even number. Plus 1 gives odd integer. So then for all m belongs to integer. Now consider n plus 9. I am considering Q, n plus 9. So what I have defined n as n is an odd number. As I have defined n as odd number, just substitute n equal to 2m plus 1. 2m plus 1 plus 9. 2m plus 1 plus 9. So expanding that 2m plus 1 plus 9 becomes what? 2m plus 10. 2m plus 10. 1 plus 9 equal to 10. Now I can take the common term called 2 in both the terms. So as 10 is a multiple of 2, that 10 can be written as 2 into 5. So if I take the common term, I will get back with 2 times of m plus 5. So now finally 2 times of m plus 5. If you consider m plus 5 as an integer, 2 into an integer, it will be an even number. So I have defined 2 times of k, where k is what? M plus 5. That implies z. That belongs to z. So therefore, as I considered n plus 9, n plus 9 is an odd number here. N plus 9 is an even integer. Then I am coming back with even integer. I have proved that n plus 9 is even integer. Thus n is odd, then n plus 9 is even. Therefore that implies that p implies q. P implies q. This is the definition of proof of direct proof. Next we will prove an indirect proof. So you know what is p, you know what is q, you know what is p, and you know what is q here. P is what? N is an odd integer, q is n plus 9 is an even integer. So now, to prove that, by definition we should assume that the result, we should assume that uh, by definition we should assume that negation q is true, p is true, and q is definitely, it will be q is false. When negation q is true, q will be what? False statement. So considering that here p is an odd integer, n is an odd integer, p is defined as n is an odd integer, then q is what? Defined as n plus 9 is an odd integer. Since q is false, I should consider false statement. What I should consider? False statement. So in the given statement, n plus 9 is even integer. So I have considered here false statement. So now consider n plus 9. So n plus 9 is nothing but 2m plus 1. N plus 9 is defined as what? 2m plus 1. Since n plus 9 is odd integer, so odd numbers can be written in the form of 2. Any odd number can be written, we can write any odd number as, all odd numbers can be written as 2n plus 1. In general, we can write any odd number as 2n plus 1. So that is what I have written there. So odd number is 2n plus 1. So considering the odd number as n plus 9, now I will shift 9 to the right hand side. It becomes 2m plus 1 minus 9. I should prove that n is an odd integer now, finally. So simplifying this, 2m plus 1 minus 9 becomes 2m minus 8. So again 8 is a multiple of 2. 4 into 2, you can take the common 2 in the step. So we will get back with 2 times of m minus 4. So 2 times of m minus 4 can be written as k. It becomes 2k. 2k is what? Even. N equal to even. Hence we have proved that n is an even integer, but negation p is what? Negation p is odd integer. Negation p will be an odd integer. If you consider p is an odd integer, negation p will be n is an even integer. So hence we have proved that, therefore negation q implies negation p, that by implication we have proved that p implies q. Therefore n is an even integer, which implies negation p is true. N is an even integer, which implies negation p is true. Hence p implies q is true. So I will define once again. I have considered the given statement p is an odd integer, q is an n plus 9 is an odd integer. Then I have considered n plus 9 equal to 2m plus 1. So simplifying this part, so n equal to 2m plus 1 minus 9, which is nothing but n equal to 2m minus 8. So I will take the common term 2. I will left out with 2k. So where k is m minus 4, which belongs to an integer. Hence I have proved that I have considered negation q implies I have proved negation p. See here, I have considered negation q. I have considered negation q. then I have proved that part as negation p. Negation p is what? Here p is considered as odd integer. I am coming with even integer here. N is an even integer. So hence it is proved. Negation q implies negation p. So that implies p implies q. Therefore n is an even integer, which implies negation p is true. Hence p implies q is true. So this is the way of writing indirect proof. Now let us go for proof of contradiction. So by definition, we assume that P implies Q is false. By definition, we assume that P implies Q is false, which is equivalent to P is true and Q is false. You know the definition of conditional statement, if then statement. If P is true and Q is false, then P implies Q is false, right? That's why P is true here and Q is false. P is true and Q is false. So now consider n plus 9 equal to 2m plus 1. N plus 9 equal to, since Q is false statement, I have considered odd number. N plus 9 as 2m plus 1. 2m plus 1. Next, simplifying that, I will get back with n equal to 2m minus 8. In the last problem, we have simplified that part and we have got that. You came to know how to simplify that by shifting 9 to right hand side. So again, by taking 2 common, you are going to get 2 times of m minus 4. M minus 4 can be written as k. It becomes 2k. It becomes 2k, where k is what? M minus 4, which that is belongs to set integer, that belongs to an integer. So we are getting back with n equal to even number 2k. So now we have proved that if n is an even integer, then q is an, then we have proved that then n plus 9 is an odd integer. Did you come to know? Did you got odd integer? Hence n is an even integer which contradicts the proposition, hence the proof. N is an odd integer which contradicts the proposition. Since p is an odd integer, that's why it is contradiction, hence the proof. This is the proof of contradiction. Now I have given one assignment problem for you. This is as similar as previous problem. Just I have given, if n is an odd integer, same statement, if n is an odd integer, then instead of 9 plus n plus 9, I have given just n plus 7 is an even integer. Then give a direct proof and an indirect proof. Just give only 2 statements, direct proof and indirect proof. Give. Okay, my dear student, try this problems by yourself. Okay, next problem, we will go with the second problem continued here. Prove that for all integers k and l are both odd, then k plus l is even and kl is a product, kl odd by direct proof. Only by direct proof you should prove that k plus l is even and kl is odd by direct proof. Did you got? Prove that for all integers, I should consider one set here, z. Then prove that k and l, they have given that k and l are both odd. K is also odd, l is also odd number. Then prove that k plus l is even and kl is odd by direct proof. Let's see how to prove that. So you should define this set, and they have given what is k and l. Let us define the set first to prove that k plus l is even here. K plus l is even. First part, k plus l is even. So consider k plus l equal to, since k is what they have given, since they have given that k is, they have given k is odd. So since k is odd integer, it is defined as 2m plus 1. Similarly, L is also odd integer. So I will define L as 2n plus 1. And I am just substituting in place of k plus L. I am just substituting in place of k plus L. So we know what is k, we know what is L, just substitute there and simplify that part. 2m plus 1 plus 2n plus 1 becomes 2m plus 2n, 1 plus 1 is 2. So it becomes what? 2m plus 2n plus 2. So I can take out 2 as common. You are left out with what? M plus n plus 1. So I can define that 2 times of k, where k is what here? K is what? M plus n plus 1, which belongs to an integer. M plus n plus 1 belongs to integer. So k plus 1, I have considered k plus 1 L, k plus L as, I have considered k plus L, and I have got k plus L as what? 2k. So I have proved that k plus L is always even if both k and L are odd. Did you got? I have proved that part here. You can see I have considered, I have simplified that part. 2 times of m plus n plus 1. So finally 2k, I have defined what is k. K is an integer. So therefore k plus L is even. Next we shall prove that KL is odd. So similarly k is odd number. KL, I want to prove that now KL, what I want to prove, KL is odd, right? KL equal to odd. So as they have defined, they have given that k is odd number. So consider k as 2m plus 1 into 2 and L as 2n plus 1. So simplifying this, expand this. What you are going to get? Expanding this, 4mn, 2m into 2n becomes 4mn plus m into 2m into 1, 2m plus multiply 2n from 1 to 1 into 2n. 1 into 2n is 2n. 1 into 1 plus 1. So simplifying this, I will get back with 4m n. No need of simplifying, just consider the common term. What you are going to get common term there? 2 times of, if you take 2 times of, if you take 2 as common term, 2mn plus m plus n plus 1. So if I name that as 2k plus 1, I have mentioned this term as k, where k is that this k belongs to integer. So it is what? 2k plus 1. So I have considered KL, I have got 2k plus 1, which means that 2k plus 1 is what? An odd number, odd integer. 2k plus 1 is odd integer. Hence I have proved that KL is odd. So here you have the proof. You can see, to prove that KL is odd, I have considered the product and I have expanded that term, taken out the common term, then define what is k. K belongs to z, hence we have proved that KL is odd. Okay. Next problem. Similarly, the same problem is given here. Same problem. Prove that for all integers k and L are both even. They have given k and L are both even. Then prove that k plus L is even and KL is even by direct proof. So just I am giving a clue for you how to solve this problem. K and L are even, means you should consider k. You should consider k as even number as 2m. Any even number is represented as 2 times of m, and consider L as 2n. Consider this main concept and solve as solved in the previous problem. Okay, this is again homework problem for you. Just solve by yourself, you will come to know how to solve this. Just I have given the clue here. Look at this clue and solve by yourself. Okay, my dear students, thank you. If you have any doubts regarding this concept, kindly message me. I will clarify your doubts. Okay.